Okay, good morning, Professor David J. De Los Reyes. Okay, my topic for this morning it's August 6 already. My topic for this morning will be a long video format, college algebra, and this is now lesson number 24. Okay, we are running smooth on our college algebra, and this is lesson number 24. Okay, let's proceed. The subject matter or the long video format discussion for this morning will be college algebra. Okay. Lesson number 24. And the title of the topic is complex fraction. Our main topic is the study of complex fraction, and it is concentrated on the so-called simplification of complex fraction. Oh, what is a complex fraction? Complex fraction is actually a rational expression. Okay? Or in layman's language, rational expression is still a fraction. So a complex fraction is a fraction that has a fraction in both the numerator and denominator. That's why it is complex. So instead of just one complex fraction, just one numerator and denominator, the problem is on the numerator there is a fraction, and also on the denominator there's a fraction. That's why the term 2 is complex fraction. Okay, let's try to bring out actually there is no rule on how to simplify a complex fraction. As long as you know your fundamental operations and you know how to simplify, okay? I use all the rules that we have studied, right? Or that's only the thing that we needed in the so-called simplification of a complex fraction. Okay, I will give you example number 1. This is an actual problem, right? Simplify, the given fraction is this. On the numerator, it's a complex fraction. It is a minus the ratio 3a over b, okay, all over small letter b minus small letter b over a. So from the definition of a complex fraction, the top portion is the numerator, right? And it still involves a fraction. Okay? And on the denominator, instead of just one simple algebraic expression, it comprises also of a fraction. So there's another fraction. So a complex fraction is that it contains a fraction on the numerator and also contains a fraction on the denominator. And the problem is asking, what will be the simplified equivalent of this one? Okay, let's try to bring out the solution. Solution. I will not follow the rule on how the book, our textbook, bring out the simplification of this. I have been teaching for a long time also, so I will give you my method on how to simplify a complex fraction. I think this is more for me. It's more clearer on how to bring out the simplification. So for us not to keep repeating, writing repeat terms, okay, we will do it like this. We will let capital letter N to be equal to the numerator. So this capital letter N refers to numerator. Instead of writing numerator, I'll just place N, capital letter N, and I will let this to be equal to the given numerator. The given value of the numerator is A minus 3A over B. So what will I do is that instead of going to the total fraction immediately, I will try to simplify the numerator separately. Okay? So we'll do it step by step before proceeding with the main fraction. It is just like attacking an enemy, okay? Instead of attacking the enemy at once, Okay, I just attack it little by little, then attack abruptly. It is something like that. Okay, so capital letter N, it will be A minus 3A over B. Okay, we now proceed with the simplification of this. So the simplified equivalent will be A times B minus 3A all over B. Okay, it's been coming out from the short videos, the simplification of two fractions, right? So actually, A is actually A over 1, right? So if we try to simplify this one, take the product of this, okay, that will be AB. Then take the product of 1 times 3A, that will be 3A. And the common denominator will be the product of B times 1. Okay, this has been coming out on the short videos. We are saturated with this, okay? So if we try to simplify this one, there is a common factor A times the quantity B minus 3 all over B. So the simplified equivalent of the numerator will be this. That's the simplified equivalent of the numerator, okay? Actually, we got half of the solution already. Next step, we will represent the given denominator to be capital letter D, and this should be equal to B minus B over A. It is this function here. So we'll try to evaluate or simplify the denominator also separately. Okay? So this will become, it's the same procedure. B is just B over 1, right? So it seems in here we are subtracting two fractions, and we have passed by that one already, right? Okay, this has been coming out from the short videos of other bloggers, okay? And we are saturated with this one. So the simplification of this one is actually B times A, that will be AB. 1 times B will be minus B. The common denominator will be the product of 1 times A, which is A. Okay? Have you seen the one doing, they are doing like this? Okay, and did he do like that on the short videos? It is this. Okay. Simplifying, there is a common factor B. A times the quantity A minus 1 all over A. So the simplified equivalent of the denominator is the product of B times A minus 1 all over A. Okay? So to bring out the simplification of the given complex fraction, okay, we will just rewrite the given complex fraction. It is this, right? But we represent this as N, and we represent this as D. Okay? And we now have computed for the simplified value of N, right? It is this. The simplified value of D is this. So it is just a matter of placing it, right? So this will now be the product A times the quantity B minus 3 all over B, all over, okay, B times the quantity A minus 1 over A. And if we try to simplify this, we will rewrite the given numerator, it is this, right? And to change the operation from division to multiplication, okay, we'll take the reciprocal of the denominator, okay, and the operation now is multiplication. So the reciprocal of this will go up and this will go down. So this will now be times A all over the product B times the quantity A minus 1. Okay? We change the operation from division to multiplication. We take the reciprocal of the denominator, multiply it to the given first term. Okay? And if we try to simplify, A times A will be A squared, B times B will be B squared. So we'll take the simplified equivalent. It will be the ratio A over B under one common exponent, 2. Okay, and the next part will be B minus 3, quantity B minus 3, all over the quantity A minus 1. So this will be our final answer. I think this is more what you call this systematic than. Actually, the one in the book is systematic, but if you are not, what you call this, good in writing, right? You always keep repeating those process, it will take longer, right? So if we try to simplify the numerator and denominator separately, okay, we could minimize the steps and the solution should be shorter. So the simplified equivalent of the given complex fraction is the ratio a over b raised to the second power laws of exponent times the quantity b minus 3 over a minus 1. So this will be our final answer. For me, I prefer this one because if I will, what you call this, simplify the given complex fraction immediately, actually the writings will be longer horizontally, okay, and you keep repeating that one. And if you are not good in writing, it's bad writing. Okay, example number 2. Simplify the given complex fraction is, it is more complex. X squared minus x minus 12 over x squared minus 2x minus 15, that's the numerator, all over. The denominator is also a complex fraction. It involves quadratic equations. It will be x squared plus 8x plus 12 over x squared minus 5x minus 14. Because if you go to try to simplify this one immediately, okay, since these are all quadratics, okay, your horizontal writing will be very long, you know. Okay, you're consuming your, the total width of your writing paper or the blackboard maybe. So for me, I will try to use the so-called solution by parts, okay? I will try to simplify the numerator and denominator separately, okay? So I could minimize my writing horizontally and vertically, okay? So I will let, and again, for the solution, okay? This is not the solution, okay? I will let the numerator to be capital letter N and the value is x squared minus 8x minus 12 all over x squared minus 2x minus 15. Okay, I make this representation and again, I will try to simplify the numerator again separately. Okay, so this will be an x squared minus x minus 12. Okay, this is a quadratic equation, so use your knowledge on how to take the binomial factors of this quadratic equation. The possible factors of x will be an x and x, right? And the possible factors of negative 12 will be a negative 4 and a plus 3. Checking the middle term will be 3x minus 4x. So the middle term is negative x. So the binomial expansion x plus 3 times the quantity x minus 4 is actually the factors, okay, linear factors of the given quadratic equation x squared minus x minus 5. So it all depends on your knowledge of the previous lesson. That's why we do first the factoring before we proceed with the simplification of complex fraction. And again, I will try to simplify the denominator separately, okay? X squared minus 2x minus 15. The possible factors of x will be an x and x, and the possible factors of 15 will be plus 3 and negative 5. Or let's try to check the middle term. The middle term will be negative 5x plus 3x, so it will be negative 2x. Okay? So the binomial equivalent of this given quadratic equation is the product of the quantity x minus 5 times the binomial quantity x plus 3. Then I will go back to that representation, then I will substitute these factored things, right? So, okay, it looks nice. So numerator now will be the simplified equivalent of the numerator is the product of x plus 3 times x minus 4 all over the product of x plus 3 times the quantity x minus 5. Okay, try to notice it. The operation on the numerator are all multiplication, and for the denominator, it also what you call this multiplication. So we are free to cancel terms for both the numerator and denominator for like terms. So this x plus 3 cancel with this. Okay? The operation is multiplication, so we are free to cancel. Okay, so what remains for the simplification of the numerator will be the quantity x minus 4 over x minus 5. Oh, that is half of the part of the total solution. Okay, let's try to represent the denominator as simply, we'll take this and represent that as d. So this will be an x squared plus 8x plus 12 all over x squared minus 5x minus 14. Again, I will try to simplify the numerator and denominator separately. Okay, so this will be an x squared plus 8x plus 12 equal to quadratic equation. So the resulting factor will be two binomial expansions, right? The possible factors of x will be an x and x, and the possible factors of 12 will be 2 and 6. Oh, let's try to check the middle term. A 2x plus 6x will be 8x. So this is correct. Okay. So the binomial equivalent of this one will be the product of the quantity x plus 2 times x plus 6. Next one. X squared minus 5x minus 14 equal to. The possible factors of x will be an x and x, and the possible prime factors of 14 will be 7 and 2. Okay? This is a little bit critical because the sign of the middle term is negative and the sign of the pure constant is negative. Okay, so supposed to be 7 should have a negative sign, so that when we try to add the middle term, it should have a value negative 5x. Oh, let's try to check. Minus 7x plus 2x will be negative 5x, and it is correct. Right? And the minus 7 times the plus 2 will be negative 14. Our sign also is correct. So the possible binomial equivalent of this one will be the product of x minus 7 times the quantity x plus 2. Then I will try to go back to my representation. I will substitute these values here. Okay, I think it is more systematic. So this will now be the product of x plus 2 times x plus 6 all over x plus 2 times the quantity x minus 7. The operation on the numerator and denominator are all multiplications, right? There is a plus sign, but it is within the quantity. So the operation is multiplication, multiplication. We are free to cancel like terms, right? So this x plus 2 and x plus 2 cancels. So what remains will be just simply x plus 6 over x minus 7. So this is the simplified equivalent of the denominator. So if I will try to go back to the original complex fraction, okay, because I represented this one as the numerator and I represented this one as the denominator, and I now know the value, so I will just take the ratio, right? So numerator over denominator, okay, the numerator is this complex fraction here, and the denominator is this one, so I don't have to rewrite it again. So numerator over denominator should now be equal to. The numerator is the quantity or the fraction x minus 4 over x minus 5, it is this. And the denominator will be x plus 6 over x minus 7, it is this. So simplifying this one, I will rewrite the numerator and I will try to change the operation from division to multiplication. So I will try to rise up this x minus 7. So x minus 7 is already on the numerator. I take the reciprocal. What will go to the bottom will be the quantity x plus 6. Okay, actually, you can now take this one as your final answer. But if you want to expand, there's no problem. If we try to expand the numerator and denominator, what comes out will be x squared minus 11x plus 28. Minus 4x minus 7x will be minus 11x. So the middle term will be minus 11x. And negative 4 times a negative 7 is positive 28. And for the denominator, it's the same. X times x will be x squared. The middle term will be negative 5x plus 6x, which is just simply x. And the negative 5 times the positive 6 will be negative 30. So the resulting simplified equivalent of the given complex fraction will be the quadratic equation. X squared minus 11x plus 28 all over x squared plus x minus 30. This will be our final answer. As simple as that one, if you try to follow my method of solution. Okay? I am not contradicting what the book says on how to simplify, but for me, I want to simplify the complex fraction. I will try to separate the computation of the numerator and the denominator separately. Then I will try to substitute to go back to the given original complex fraction. Okay, so for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@prof.dbj. If you want to share it, please click share. Try to watch my long video format college algebra. You will learn something from it. Okay, good evening from Los Angeles, Professor David J.